Okay, we're gonna get started. As most of you have seen, last week DreamWorks had some exciting announcement around open sourcing their MoonRay renderer. So I would like to invite up Andrew Pearce to talk about it some more.
Hello, everybody. I want to first thank ASWF for making time for us to talk here today and asking us to come up and talk about this. And I appreciate your time and interest in coming to hear about it. Big green button, right? Am I not pressing the right green button? There we go. There we are. So MoonRay is our production renderer. What we're going to show today, there we go. We're going to start with the sizzle reel. We're going to talk a little bit about the motivation for why we're open sourcing it. We're going to introduce MoonRay here and just kind of talk about the features, how it was designed, how it was built, highlight some of the features that it has, and then, you know, probably the most interesting part for all y'all is opening it up to questions and talking about what this thing is and what we hope for it. For me, the most exciting thing about it is it's going to change, and that's you know, what bringing it to open source means. So, but first off, let's roll the sizzle reel if we can, please. Just makes you want to dance. As you can see, we kind of went through all the data sets out there and tried to show examples of just what's capable with this. So to start with, let's just talk about why we're moving to open source. Like what's the motivation there? There's kind of three big ones. You know, we continue to demonstrate our commitment to open source. OpenVDB is something we gave to the community. We saw how that grew stronger and grew better and bigger and bigger than anything we could have done internally. So we're hoping for some similar trajectory here. we want to engage with partners. Giving this renderer away is very altruistic of us, except that we're also looking for selfish benefits for it. So, access to the super smart developers in the open source community, finding a way to kind of control our own destiny, to pool our resources to go forward. And also just, if we would like to use this on partner studios at DreamWorks, having people out there that already know it, that don't have to be taught it, having availability out with our vendors is of value to us. So these things are amongst the reasons why we're open sourcing it. To talk about what MoonRay is, I'm going to introduce Randy Packer, who is our manager for the rendering team, to kind of go through some of the details here, and then we can talk about the questions.
Which button do I push, Andrew? The big green button? Okay. Well, I don't have any speaker notes, so I'm gonna wing it today. So yeah, MoonRay, what is it? It's our production Monte Carlo path tracer. I would describe it as a forward ray tracer with forward path ray tracer with next event estimation on it. For all these reasons, we think it's good. It's built on a modern architecture. We started this just about 10 years ago, but it didn't go on to our first movies. It started with How to Train Your Dragon Hidden World 5 years ago. It's built on the principles of separate integrator, the Ombre as a ray tracing core, and then closures on top for shaders and procedurals. High performance has always been a key goal of MoonRay. It was started with this in mind. It was intended, or actually originally intended as rendering as a service. So we did want scalability up to real-time rendering, multi-machine, multi-threaded, vectorization, XPU. Well, along with the data-oriented design, we did take a background from the gaming world and really leverage all of that good stuff as well. Our mantra, keep all the lanes of all the cores of all the machines busy all the time with meaningful work. This has been our mantra all along. This is what we adhere to. It is bundled wavefront path tracing. I don't want to read the slides. You guys can see that. Yeah, no locks. We do have a couple of developers here. Keith can speak about our locking system. Dan's here. A lot of people online as well. Eris is our multi-machine distributed in-house cloud framework for distributed computations. MoonRay and Eris were built kind of lockstep at the same time. And yeah, everything is sent out to distributed nodes for rendering and then processed back with a single merge node on the way back in. This is just a little overview of that. Yeah, how far have we scaled with Eris? This was a test that we did a couple of years ago, I think, with the CRUD's 2 NAP scene. It was linear. We ran it on 96 nodes from Azure, from Glendale to the Azure West region. I think these were 128 gigabyte hosts, 64 hyperthreaded cores for about 6,100 hyperthreaded cores in total. We don't know where the ceiling is hit. We haven't tested that far out. So we don't know how many nodes it's going to keep going linear at. Since last year, we've actually started on a Hydra render delegate. We have it working. It's working pretty well right now. Our intent, MoonRay's internal scene description format, we call RDL. Our intent is the Hydra delegate will be the canonical way to get USD into MoonRay, not just for interactive preview rendering, but also for final batch rendering. And that's available right now for the interactive preview rendering. So let's talk a little bit about AOVs and light path expressions. Every modern renderer worth its salt does this kind of stuff. And we certainly support that as well. Material AOV is a little bit unique to us, I think. This just exposes some diagnostic information to the artist at the intersection point of the VSRDF. And so it does not concern itself actually with the transport of the ray, but actually the intersection on the material. And some examples of that look like this. Display filters is also something that we've added up there. These are not every highlight in the artistic toolkit. I'm just highlighting a few things up here. So these are compositing nodes that can be piped in from AOVs or other display filters, multi-threaded and used in MoonRay for typically non-photoreal workflows. Example, here we're grading the bounce light. Whoops. I think it turned it off. There we go. I don't know how to go back, but here we're oh, thank you. Are we back? Good. Grading the bounce light, taking the green off of the widget there with a simple node-based filtering system. Now we have our tune display filter. It's an example here. We have a suite of efficient and layerable materials, common material types, a Uber shader for general purpose and more complex material layering. It should be pretty familiar for people who have worked with similar systems in the past. And a couple of examples of layers. Vectorization. Vectorization was announced, if anybody saw it, at HPG in 2017 by our friend and colleague Mark Lee, who's actually in here. This is one of the more unique features of MoonRay at the time. I think it probably still is. I'm not going to go into all the details about the vectorization, but this just shows the path of the bundled rays through the queuing system. So here's some results. I didn't know I was going to give a talk today, so I pulled these results from earlier slides. So if you've seen these, forgive me, but they still hold true today. So this is an example of an asset from Trolls. This is Bergentown. Here we see that integration took up a fairly good amount of time, and in the vector version, it went down pretty significantly. Specifically, the biggest section there was the shading subsection with the 6x speed up. This is Astrid from How to Train Your Dragon. Let's see. Here again, a lot of time was spent in shading, particularly texturing and integration. And we see the shading system speed up at 4.5x on the vector mode. This was an asset, it's called Hotspur. Here's a pretty good example of everything that we would hope that vector would help us with in terms of shading and the texturing and the integration. Total 4.2x speed up. So how do we do in terms of what is all this great efficiency with MoonRay and how does it help our movies? So these are the rendering core hours. This is for every movie that we've done with MoonRay. This is the range of how much RU that we're spending on our movies. Final thoughts. MoonRay is just beginning. This is an exciting time for us at the beginning. We're really excited to partner with everybody out there. We're glad to see some interest. We are still growing production features. We're open for all kinds of great work coming out of the community, and we're happy to talk with you. And I think we would open it up for questions now. Get to the good stuff. Thank you.
And Emily said that if there's questions in the Zoom, she will read them out.
Yep.
Just raise your hand if there's anything. Oh, here, the microphone's coming to you.
So is there, I think I saw something about GPU support.
Yeah, we use the GPU as a coprocessor. So we schedule rays onto it currently. So it is just for occlusion rays right now, but the whole shading network is vectorized. So there you can envision somebody taking on a project in the open source community and do vectorizing the shading.
Okay, thanks.
Did I get the wrong?
No. Everything you said was fine. I'll just add in that it is pixel matched because we're leveraging our bundled architecture to throw specific rays at the GPU. And if the GPU is not on the machine, then we just fall back and process everything on the CPU.
Back. Yep.
Hi there. I was just wondering if the renderer is tied to any specific DCC, or could it be integrated one day into Blender?
If Blender supports the Hydra delegate, that's the way you get it into there. So yeah, it's not tied to any one particular DCC. In fact, when this was first built, it was envisioned to kind of be a standalone where you'd have a very lightweight, thin client, and you'd have all the resources being used in the back end to do the visualization for something that was not feature film related. So it's physically based. It wants to be accurate and fast.
Thanks.
I think the person way in the back was first.
Hello. So part of the motivation behind this was to get people in the community, to come with prepackaged experience with using MoonRay so that partnerships are easier. Are there any planned community outreach or growth programs in the works for sort of fostering that community? Because this is all very new to, open source devs.
Certainly we're going to establish a TSC, technical steering committee for it, try to get people involved. We're beginning outreach to a lot of educational institutions and other companies. So yeah, we're keen to explore what that means. Most people have had experience with an MCRG ray tracer at this point in their life. This is a particular instance of it. It's got some great unique features, and it's got some common features. So hopefully it's not a completely foreign entity to people. But yeah, we're interested to hear what kinds of outreach we can do to make that work.
I'll add in too that on the openmoonray.org website, we do have interest signups. We're going to probably put up forums up there, and there is an email alias to the MoonRay team, so you get to speak directly with the developers. Send us any questions.
Yeah, and that sizzle reel video is also linked from the website and on YouTube. So if you wanted to look at it more.
Hello. So it sounds like in terms of integrating it, you're encouraging us to use the Hydra API. I've been hearing from some other renderer devs some performance bottlenecks with Hydra 1 and lots of excitement for Hydra 2 and what that might look like. But has Hydra been a performance bottleneck in your experience?
Our integration is custom to a DCC currently, so we're not consuming that, but we want to go to that. We want to stop supporting our own custom integration and go to Hydra 2 once it's out. That's what we think that the new interface is going to be, and that's going to be the easiest way to connect all the DCCs.
I'll add in as well that we are also running it in the USD preview render, and we've been working with Pixar, collaborating a bit with them since last year, discussing the API and the plans, the future roadmap.
Hi, this one is related to that. For Go Interactive, you said that you had to go through the Hydra delegate, but to render offline, you can imagine a full USD pipeline. You can convert to that RDL format and just render from there. Can you?
Yeah, all of our rendering in batch is done via that. So there is a way to translate the USD, because we're pretty much a complete USD pipeline as well. And you can translate that to RDL that gets consumed. And all the standard stuff, checkpoint rendering and things like that are there as well. So yeah, there's a full batch interface for it. You don't render 92 million render hours without that.
Thanks for mentioning checkpoint and resume rendering. We do also support that. We checkpoint our renders We can checkpoint based on quality, time, or signal based. If we want to evict a job, move it on to something else, you can think of scenarios where you do like least cost routing, that sort of scenario.
One question I have is what kind of, I guess, production scale are you expecting with the renderer? Like, for example, are you expecting someone in their bedroom with their computer to be able to render some frames, or of course, do something up to like, DreamWorks scale?
Yeah, if you've got enough money to rent that many cores to do something on that scale from your bedroom, that's fantastic. There are other renderers available to you, so people could be doing this now. So yes.
I'll double down.
Yeah.
Yes, it's all of that. It can scale up from one machine to many machines. So.
Hi. Do you support plugin systems for procedurals? And if so, how complex will that API be compared to other renderers?
What
Plugins for procedurals?
Plugins for procedurals? Yeah, we supported plugins for procedurals. But what's the more specific question?
How complicated is it? How similar is it to other renderers? C++.
Yeah,
I will guess it's C++,
Yeah.
but it's not the same building a procedural for Arnold than it is for Redshift, for example. So in that line, how mature will you say you focus on that versus your custom developments that you do that you might not need?
How much will we focus on building shaders for or procedurals for?
For geometry more than shading, but in general.
I haven't looked at the other renderers procedural API, so I can't make a comparison, but I am more than happy to talk to you about the procedural if you want to talk to me afterwards, or I don't know how much time we want to spend expanding here. But yeah, there's a C++ procedural API that is efficient, and I don't think it's too onerous to use. And yeah, happy to talk to you later.
Back table.
Do we have some hardball questions like how awesome is this? Or
Hi, just to understand, is this being entered into the Academy pipeline for projects? Or are you just speaking here, but you're doing this on your own?
Yeah, so right now we are just open sourcing it. We're trying to get to that point by the end of the year. There's been no talk with the Academy Software Foundation yet because we just sprung them on this on Friday, sprung this on them on Friday. And yeah, who knows?
Okay, thanks.
Yeah, just to reiterate, I know it was in the press release, but just in case you didn't hear. So we're going to go back after SIGGRAPH. We're going to scan through all of the submissions on MoonRay.org that for people that want access to the early beta, pick out the number of customers that we can actually really support in this time. Looking for people that are going to be able to take the pain of like, hey, we've just extracted this system from a proprietary tool set and maybe it doesn't build right. Like we think we're kind of there, but there's going to be a little bit of pain to start with. And so we want people to go through that with us as we get ready for a rollout later this year where everybody can have at it. So that's kind of our timeline there. In case it wasn't clear, the Eris framework is also something that we're contributing as part of this as well, so that you can do distributed rendering all for a single artist. One of the values that we really found there is that you can do not only just distributing a single scene onto a number of remote machines to accelerate the artist's experience with the full scene, so they're getting back exactly the pixels that are going to render. But you can also start to do some multi-context things. So you can have different lighting conditions. If you're evaluating the surfacing for your vehicles, you can have multiple groups of Eris nodes that are working on different lighting conditions or different times in a scene or different shots in an environment, et cetera. So you can really leverage the power of a single lighter to do a lot of work on your shots. Question back there.
Speaking of the distributed nature, is it data distributed, or is it tile distributed, or image-based distributed?
It is data duplicated on every node to make sure that any node can render any sample. And we don't distribute tiles. We've got a way that the samples are distributed amongst the machines. So you're not really seeing a tile come back in those examples you saw. The scene just kind of resolved. Because every machine will do samples in pretty much every pixel, that gives us our robustness. So if some node goes down, it just converges that percentage slower from missing that node. It will still converge. So that help. People have talked about the economics of giving a single lighter that many machines, but again, if they can light that quickly, I don't want to say the next part of that, but you can maybe go to.
So the lockless part made me wonder, have you looked at ARM support? ARM, like Apple Silicon, and because it's a little more tricky when it's lockless.
No. Do you want to expand on that at all, Keith? The answer is no, but.
Well, to be honest, I think we are mostly focused or have been focused on making it work for our needs, which is we've got a bunch of x64 machines and we've just been focused on that. And we do have a lot of, we use a lot of kind of low level parts, like we use the AVX2 system and we're using, you know, all the SIMD registers. And so we haven't looked at ARM because mostly we haven't needed to. But with the lockless architecture, you know, as long as they support 64-bit atomics, it's probably okay. So even though the x86 memory ordering is more strict than the ARM, we do pay attention to our atomic ordering. So in theory, we haven't tried it, but we hope that our atomic ordering is correct. So we haven't tried it.
I was going to key in a little bit about what you were talking about, the scale and the multi-machine as well, that the way we distribute the pixels also means, of course, no checkerboard renders, which is nice. When it comes back, the interactive experience, if you look at the sizzle reel, is quite good. You know, we made some improvements in the last year. We brought down the latency from about 1500 milliseconds to 150. And it scales with the number of machines. So you're getting pretty good interactive experience through that system as well. And then the anecdote that I remember is we had a marketing frame at some point, or a marketing still that we took about 15 hours to render. They needed to make a change and turn it around, so they just stuck it on 3 nodes and got it back within 5 hours. Or maybe it was 5 nodes and got it back in 3 hours. But yeah, it's pretty good linear.
Question in the center table.
I'm pretty sure the answer to this is going to be, it's up to us to figure this out, but open shading language, I think it sounds like you guys aren't playing with that currently. So I assume that's something for someone else to look into.
Yeah, we're using ISPC as our shader language, which is you know, C-like with a couple extra tokens in there. I think it would be a fantastic thing for the community to write a compiler that would compile, you know, open shading language OSL into ISPC for that reason. So yeah, but we're going to ship it with a number of, you know, almost all of our shaders, except for one specific one that we think is very troll specific. We are happy to continue the dialogue again offline. You can find us around. You can get at us at openmoonray.org. So thank you for your time, everyone.